So I'm going to show the old way of, in Gen Chem 1, how do you go about figuring out the excess and the limiting reactant. But what I want you to know is why it's so useful and such a great tool to use an ICF chart instead. And that's what's coming up. So I'm kind of trying to remind you how annoying it is to write out all these equations. So before we write it out, make sure you see that we have a balanced reaction right here. Notice balanced. And the the key thing is that when you get to where we are in Gen Chem 2, we're trying to figure out about buffers. And buffers have this weird kind of salt-acid combination together, and we need a value for each of them. So that's why I have two parts. First, we've got to figure out how much salt is produced, and then how much left over of whichever one we have left over, either the base or the acid. All right, so the other thing is, remember that that is the same thing as this many liters. That's just dividing it by 1,000. And this one is the same thing as 0.050 liters. And then this is also the same thing as moles per liter and moles per liter. Now, ultimately, what I'm trying to do here is I'm trying to convert into NaCl. But in one case, I'm going to use the NaOH. And in the other case, I'm going to use the HCl. I'm going to see which one is the least, and that's going to be the one, that's going to be the real amount of NaOH that's generated. So I've got 0.100 liters of NaOH and 0.050 liters of HCl. So I'm just writing those both down from the problem. And then what we do is we would go from liters of NaOH to moles of NaOH. And then I would go from moles of NaOH to moles of NaCl. And then on this one, I'll go from liters of HCl to moles of HCl. And then from moles of HCl to moles of NaOH. Take the information from the problem. Up here is where I've got my NaOH amount. So that was 1.0 in 1 liter. I might erase it so it's easier to see. And then on this one, it's 0.50 moles in 1 liter. And then in the problem, 1, 1, 1. So all those coefficients are 1. So that's 1 to 1, and that's 1 to 1. So when I get my answer, this is just being multiplied by 1. So, oh, and I just noticed the typo. You probably just noticed it already also. That one is 1 mole per liter. There we go. Now it's all good to go. So this is just 0.1 times 1. So that answer is going to be 0.1 moles of NaCl. And then the next one is going to be 0.05 moles of NaCl. So that's going to give me an amount. This is not the real, that's the excess. This is the real amount, that's the limiting. This is the one that gets used up. So then for my leftover excess, what I'm going to do is I'm going to convert. Aren't you having fun? Do you remember this? My liters of HCl into my moles of NaOH, so I can figure out how much of moles of NaOH was actually used. So I will say in 1 liter of HCl into moles of HCl, and then I'll go from moles of HCl into moles of NaOH. And then this was 1, and that was 1 to 1. So I've used 0.050 liters of NaOH. And then to find out how much is left over, I got to subtract out the initial amount that I had. That's not liters, that's moles of NaOH. And so I go up here, and I have 0.1 times 1 would show me how many moles I had, which was the 0.1 moles. 0.100 moles of NaOH. So then it tells me that the amount that I have left over, moles of NaOH, is that number. Now I have the two numbers I put in my chart. And you'll see that when we do the ICF chart, it is so much faster than all of that.